Good morning, YouTube. I hope everyone's having a wonderful Friday. And today I'm going to be talking a bit about our critical rendering path. This talk is for you if your site has been switched to mobile first index, your site uses JavaScript, so you're part of the 95% that do. Performance is a ranking factor for your site, or you'd like users to convert in general. Do I have everyone in the audience now? Probably so. And if not, how did you find this channel? This talk is for me if I'm Jamie Alberico. I'm not a robot, but I speak bot. I'm a notorious blue-haired SEO who likes to talk about tech, so rendering, JavaScript performance metrics, or if you just want to play D&D sometime. We're going to talk about today what the critical rendering path is, how to measure it, and how to optimize it. Step one, what is this thing? Scary, scary technical words. Don't worry, it's not that bad. Critical rendering path is simply the steps your browser has to take to make a page, and more specifically, to make the content visible to the user. So for most of us, most experiences, that's what we already call above the fold content. Simple formula, yeah? We have a user, we have a screen, and we have some content. Shouldn't be too bad. Well, we typically think it's going to be like this. Real easy, broad strokes, huzzah. It ends up looking like this most of the time. This is the full page laid out for mobile. And you see I had to flip it to actually fit it fully on the screen. So when we talk about critical rendering path, we're talking about that initial viewport and what the user can see versus all of the luxurious content on your page that no one's going to stick around to see if it doesn't respond quick enough. Let's build it. Let's make a page. We'll pretend that we are browsers, that we are bots. And we're going to make our document object model, or DOM, our CSS object model, our render tree. We're going to do some layout, and then we're going to paint. Fancy word for putting pixels on the page. Step one, build our DOM. So we start with our initial HTML. Most SEOs know that out there as our view page source. The HTML is red. It then goes through and grabs all of the resources needed to build that page, and it constructs the DOM. Here's a little bit of what that looks like. We have traditional elements like opening HTML tag, a head, a body. Step two, make the CSS object model. This is where we take our style sheets, we parse them out, we develop style rules. It's important to note that we can make multiple style rules. We can override things. So while we may have a default value, say font size 16, we could override that with another style rule that says, no, it's bold, no, it's red, no, it's this. Step three, make the render tree. We combine these two things together. We have the content that will be on the page, plus how it looks. So basic text on a page and how pretty it is. Not too bad. Step four, make a layout. This is where we identify our requester and what their needs are. What is their viewport? Are they in portrait mode or are they horizontal? Then we begin to paint. Process of taking all of our rules, our pretty styles, adding it to the content we found in our HTML and building it out onto the page. Oi, what about JavaScript? I know I kind of teased and I promised here that this critical rendering path was the place where performance, JavaScript, mobile first all combined together. Well, where was I talking about JavaScript in any of this? It was already all around us to begin with. JavaScript is a unique and precarious little beastie that can pop up in a number of places, even where you wouldn't expect it. So when we look at this from a performance perspective, our initial HTML response is that time to first byte. And when we get to our painting, we have got our first contentful paint. And I show you our above the fold render content here, and JavaScript actually can extend further out into that. So for sake of simplicity, we're going to leave that there. How do we measure this thing? Luckily for us, it's pretty well laid out for us. You don't have to go to DevTools. Honestly, DevTools is not really designed to be the most effective way for you to measure a critical rendering path. We have option one, Web.dev. So we're all used to Lighthouse. We used to have these lovely little extensions, and then it became part of Chrome DevTools and the audits feature. And then you forgot to go ahead and disable an extension, or you had cookies enabled, and it became inaccurate testing and a waste of your day because, yeah, you had to do this all one by one. Web.dev goes ahead and does that for you. Make sure that we're replicating an adequate experience, an accurate experience, and you can track changes. Very lovely. You can download the results as JSON or HTML. So if you are doing this at the very start, you can learn by doing some one-offs. The cons for it, it's a one-off. So if you want to get that proof of concept out there to your dev team, get the buy-in, say, look at what we can do when we leverage this, here you go. This is the output of what we get. Really quite lovely. There are scores. Those big numbers, of course, make our stakeholders pay attention. No one likes to see the big red sad. Everyone likes to see that big green happy. Option 2, be cool like Dan and automate with Lighthouse. Automation is cool. More tests or more data. More tests or less blind spots. You can slice and dice data in really fun new ways. You can store results and visualize the changes. Someone just posted a really cool notebook recently on taking this data and putting it into Google Data Studio. If you are an enterprise level, I recommend using a log file analysis tool, visualization tool like Kibana, anything like that's very helpful. You can also test in lower environments. This is very, very handy. In a perfect world, SEOs aren't goalies. We're not perpetually trying to stop the bleeding. I like to call that a reservoir dog audit because you're yelling at the site to say the words, you're not going to die. In this scenario, we get to find out in the lower environments, hey, did that new cool tool we added kind of add 5 seconds on how long it takes a page to load? If so, let's circle back on that. Some cons to it. You have to have a dedicated space. These files will build up. If you don't remove them and check in on them, things go cattywampus and sideways. There are great tutorials out there. I highly recommend it. Not as nearly as scary as it may sound. We get a great visual like this, thoroughly stolen from Dan's fantastic blog posts on automating these. Option 3. This one is so cool, guys. It really is, because you have real world data of the critical rendering path of user experiences on any page. And that's beautiful. You're not playing sampling games. You're not playing, well, hypothetically, this is what the emulated data looks like. No, this is real humans. This is like a bulked up version of the Chrome user experience report, but you have the responsibility here. You'll have the onus of not only installing this on every page type, but also keeping track of your data. Takes a code base, or everything is code base. Takes devs to do to every page. You have to track your own data. Very useful, but heavy lift, high impact. We can get some really cool milestones from this. So things like DOM interactive marks when the DOM is ready. DOM content loaded marks when both the DOM and our CSS object model are ready. If there's no parser blocking JavaScript, our DOM content loaded will fire immediately after interactive, and DOM complete marks when all of the pages and its sub-resources are ready. A lot of times we talk about performance in a number of ways. Everything from, well, my page loads in 4 seconds. What does that mean? To here's our time to interactive. And this critical rendering path ties back heavily to our performance metrics. So when I say you care about this talk, if your site is impacted by your performance, critical rendering path is another way of looking at the time to interactive. Time to interactive is part of that big happy score we saw in the Lighthouse bar earlier. It means the amount of time it takes for a user to not only see the content on that page, but to interact with it. And it's measured forwards in the viewport. So all of these things overlap together, and really a lot of us are talking about the same things in different ways. We all have very similar goals. So how do we optimize this malarkey? Now that we know about it, now that we hopefully care about it, don't block the rendering. The next time a vendor comes to you and goes, yes, my Cube Unicorn Magic Score will tell you everything about SEO on your site. Just simply install this tag directly below the opening head. Tell them no. Tell them not today. It's not a great time for you. If you're trying to message me right now, I can't see things. Cool. Don't know if you guys can see that. We've got 3 types of render blocking resources. First of which is going to be a script tag. So any tag in the head of a document that does not have a defer or async attribute. So every innocuous pixel, every call to a font bundle, all of it is going to have an impact here. Style sheets. CSS is inherently blocking. We have to go get that content. It's part of how we take what we know will be on the page and then we turn it into what we know it will look like on the page. If your style sheet does not have a disabled attribute and a media attribute that matches the current device, it is blocking. Any HTML import that does not have an async attribute is blocking. This is one of those times where you can go ahead and flex your muscles with your dev team, pull this open, look in the head, and find out how many places do you have an opportunity to make your site a little bit faster by making it less reliant on external resources. Protect the head. It's a very important piece of your site. Everything from canonicals to Ahrefs, all in there. Title tags, every last bit of it. And if we have some of these blocking resources, like I mentioned before, that happen to be synchronous third party, that means that we are saying, okay, hold up, I'm just gonna go run and grab one thing real quick. If that third party that you have no control over takes too long to respond, this can result in the head prematurely closing. When that head prematurely closes, you have decapitated it. All the content that you deeply care about and you've worked so hard for optimization is now gone. And we have this spooky site. Keep our resources small. When we're bringing in the pieces we need to build the page, we bring more than we need to. It takes a while. It's bulky. Remember that Google is working from a mobile-first standpoint because the next billion users will be on mobile devices, and they will not be on deluxe mobile devices. They will not be on a infrastructure as many of us are used to having, and we are quite privileged to. So we want to keep our sites built for the next billion users who will have mid-range devices, such as a Moto 3G. They will be using throttled 3G networks. We can do this by taking the resources we have now and making them as small as possible. This isn't something you manually do as an SEO. This is something you cooperate with the dev team to do. There are some great tools out there like tree shaking, code splitting, minification, data compression. What we want to do is remove everything that doesn't contribute. So if you're packing for a vacation to go skiing, perhaps you don't need to bring a snorkel. Maybe you do. Maybe it's a very special mountain range, but it's a place where let's shake the extra weight. Let's get rid of things we don't need. Minification will be taking out all the comments, unnecessary spaces, nothing that will impact you as a user, and it's done in an automated way. We can also split up our bundles. Let's optimize them for what a browser is meant to use. Browsers are already optimized out of the box to go ahead and handle a number of things like creating our CSS object model, our direct object model, document object model. They are made for 1,600 nodes total. There's a spider about to run across my webcam, guys. He's making a cameo right now. It's optimized for these things. And when we go beyond that, we begin to make more calculations, take up more time. But let's split these out. Let's leverage basic technologies like HTTP2. That gives us multiplexing. We get to make multiple requests rather than having a single queue. It's a bit like when you are in line somewhere, there's only one teller open and then someone else opens up. It's very lovely for all involved. We're going to avoid critical request chains. This is the example of what you'll see using Web.dev as output. They do a lovely job of telling you exactly what's going on here. To put it in a little bit more context, what you're seeing right now is called a request map. It's a visualization of every request needing to go ahead and make a page. This is not a particularly healthy page. A request chain is when our site has a third-party script, and that script calls a script, and that script calls a script. And then finally, that goes ahead and grabs some pretty icons and stuff. So this new functionality you may have added because it had some really cool bells and whistles. It's a long path to get to those bells and whistles. It may be worthwhile considering, is the impact of this feature on my site's performance worth what it provides? You can objectively measure this. Go ahead and look at your KPIs, figure out how much each second of load time added reduces your conversion rate. There's real numbers behind this, and those get attention a lot better than a softball argument of maybe we shouldn't block the entire page for 5 seconds. Who knows? Load only what you need. The best way to optimize a critical rendering path is to not load things. To remove what is not beneficial to us. So if we want our page to load in 5 seconds for that next billion users, on that 3G connection, we have about a meg and a half total for our page size. That's it. We need to make this quick. Every script you call, whether it actually does anything on the page, has to go through a whole series of actions. When that's JavaScript, that takes up a whole thread. That means nothing else gets to work. When we look at our thing we call crawl budget, that's made of threads. If we've occupied our threads with useless JS, perhaps a search engine wouldn't be so kind as to invest their technical debt in our site. If we do need a resource, only download it once. Best practices, we want to keep JavaScript, CSS, everything below about 500 kilobytes. We don't want to repeat ourselves. So happy path world, we've got one CSS file. I'm not going to go into JS because that comes down to how your site executes it. And we want to reuse things as long as possible. If you go ahead and you were to look at your main thread processing and you see something like this, be terrified and tell someone, because we're going ahead and executing resources that are taking a long time. When you see this level of complexity in scripting, perhaps it's because we're writing something, then rewriting it, then rewriting it, then rewriting it. It's a good, easy way built into our dev tools to look at if we are shipping scripts that are not necessary. And that is in Chrome Dev Tools, clicking on those 3 dots, going to more tools, going to coverage. When we go ahead and do this, we can see how much of each script was used. If you see a very robust bundle, that's half a meg in itself, and it's 98% unused. This is the time to go ahead and work with your team. Let's look at ways that we can build into our release process, removing code that is not useful and minimizing that which is. Prioritize what we load when. This bottom one here, this is the idea of it'll all come together at once, but you have to wait longer on those moments, those seconds where a user's thumb is hovering over the back button, or they're really tempted to go open Instagram. They might not come back. You are losing their attention. You are losing their conversions. When we optimize our rendering, we load what matters when it matters. No one cares about your footer when they haven't seen anything available to them in the first place. We can skip requesting our resources for CSS to get that visualization of what we've already put in the HTML by inlining it. So when we inline it, we're actually going to make a statement of saying, hey, this content above the fold, this is blue, it's this size, this is bold. By doing that, there's no wait for the CSS to come back. Quick, on the fly, great experience. We should inline this content for the initial viewport. So again, the above the fold content, that which we see in initial page load. And the CSS should appear before you make calls for external style sheets or JS. Important little technical nuance. We want to cache these as long as possible. If you had to go through all the trouble of executing all these scripts, and then you had to do it again every single time, you as a human or bot may find it a bit tedious. Best option here is to go ahead and once we've gone through that effort, use it, keep using it. So extend max age can be used on JavaScript and CSS resources. Each resource should explicitly state its caching policy. It should answer, can it be cached? Who can it be cached by? how long, and how often they should check to see if any changes have been made. We can do this really cool version compare. We go ahead and leverage our cache control and e-tag headers. Cache control defines how long and how resources can be cached for browsers and intermediate responses. So CDNs, pieces like that, very useful to us. Our e-tag is a revalidation token. Basically, we have a sequence here and a sequence here. If these two match, we reuse. If they don't match, then it's time to go ahead and fetch a fresh copy. Most important piece to this, make allies. This is not something that you will win on your own. And every member of your team and our community, we have the same goals. We want to make a better web, want to reach more users, and have a pretty fun time doing silly webinars with good folks at SALT. Thank you, guys.